Assalamu alaikum everyone. I am Maisha Islam. Today I am going to represent the paper ID 228 with a comparative analysis of machine learning and deep learning models for discriminating autistic versus non-autistic spectrum disorder using facial images. The outline of the presentation shows that the abstract, introduction, literature review, methodology, proposed work, result and discussion, conclusion, future work and references. In the abstract, we have seen that this work investigates the development of prediction models for the diagnosis of autism spectrum disorder (ASD). Multiple machine learning (ML) and deep learning (DL) models have been compared in these studies. Also, this proposed CNN model, which is computative neural networks model, demonstrated superior accuracy compared to all other machine learning models. In the introduction, we have seen that the present study introduces the prediction models for the diagnosis of ASD in children are developed using methods for machine learning and facial image analysis. The research contributes the following. Number one, this investigation involved the application of multiple machine learning and deep learning models to determine the most effective models. Secondly, the publicly available datasets from Kaggle were utilized for these studies. Thirdly, a modified CNN model was proposed and implemented. And additionally, we can say that the result of this study were compared with the work of other researchers to evaluate its performance with the help of confusion matrix. In the literature review, we have used the most recent and most relatable literature review according to our proposed work. In the year 2021, the author focused mostly on classification model utilizing CNN, but the limitation was they did not focus on machine learning. Comparison to our work, we have focused on both machine learning and deep learning. In the year 2023, we have used YOLO version, the authors have used YOLO version 8 model in deep learning, but as a limitation, they did not use CNN model. As according to comparison to our work, the CNN model was used by us. In the year 2024, the authors emphasized on the deep learning only, but they did not emphasize on machine learning. But in our work, we emphasized on both machine learning and deep learning. In the year 2024, we have used transfer learning in conjunction with a convolutional neural network. It did not compare machine learning to deep learning CNN. We have compared machine learning and deep learning, and also we had found that CNN provided more accuracy. In the methodology, can see that the methodology and proposed system are adapted for these studies. As a deep learning and both machine learning, both has the same points for splitting and crossover of the data. These are training data, testing data, and validation of data. They also have the data pre-processing, which is the same. These are resize, filtering, flip, rotation, noise removal. As the feature extraction, the deep learning has the CNN convolutional neural network, but machine learning has the feature extractions like SVM, then KNN, K nearest, then the NB, which is naive bias, and also have the LDA, and they have a DT, which is decision tree, and LR, logistic regression. Both of the feature extraction is processed into the training models, and after that we have gone into the true levels as output, which is autistic or non-autistic. As the data preparation, we have used the 2926 JPG images with a resolution of 224 into 224 pixels has been used. The dataset is categorized into training, validation, and testing sets. And also for feature extraction, it used flattening. That means each image into one directional vector. Figure 2 image sample A and B both has boy and girl with autism, but C and D boy and girl without autism is used. In the machine learning method, we have we have put the input into the dataset. After the preprocessing step, we got the feature restriction, and these are passed to through the splitting data and cross validations in 3 steps, like training data, validation of data, and testing of data. After that, applying 6 classifier, then we got the best classifier, and which is among chosen. If L0, then it is level as L0, which is non-autistic, and L1, which is autistic, as output. The pipeline optimization of the data machine learning models, we can see here are defined, which is specified data set, then resize set common image, then train classifier with training features, then test chain matrix and matrices for test set, save as the trained, and model is SVM model. The proposed CNN model is used here as the input image. We have used a clearly visible layer text input images, typically resized to consistent dimension, for example 64 into 64 into 3 pixels. We have used 3 convolution layers to apply filters to the input images to create feature maps. These are 3 into 3 into 8, 3 into 3 into 16, and 3 into 3 into 32 pixels respectively. We have also used the max pooling layers of 2 into 2 pixels for reducing the dimensionality of feature maps by downsampling, and we have used kernel of 3 into 3 pixels in these 3 layers. And we have also used 3 ReLU layers, which are activation function, to get the output probability of each class. As CNN pipeline performance metrics, CNN model parameters for training. These are mode is used as training mode. The image height and image weight is used as 64. Image channel is 3. Number of classes is 0 for non-autistic and 1 for autistic. Normalize the coordinates for true. Base size is 32. Epochs is 20. Convolutional layer is 3. FC layer is 2. And ReLU activation function layer is 3. The prediction performance model is a matrix is used here, that is TP, TN, FP, FN. TP is true positive, which individualize an autistic as an autistic. TN is true negative, which individualize a non-autistic as non-autistic. FP is equal to false positive, which individualize a non-autistic as an autistic, and false negative is individualize an autistic individual as non-autistic. For accuracy, we have used the formula TP plus TN divided by TP plus TN divided plus FP plus FN. For precision, we have used the formula TP divided by TP plus FP. For recall, we have used the formula TP by TP plus Fn, and for F1 score, we have used the formula 2 into precision into recall divided by precision plus recall. And as the result discussion, we can see in the figure 6, confusion metrics for CNN model are 90 and 75 for TP and TN respectively, and 25 and 10 is for FP and FN respectively. And for the accuracy, figure 7 depicts the CNN model illustrating its accuracy and loss across iterations. The model is trained over a maximum of 380 iterations, with each epoch comprising 90 iterations. Result and discussion. The comparison with other work in the table 3, it is comparative analysis of all machine learning models is used here. SVM is accuracy. You can see that SVM has the lowest accuracy and F1 score. It is 62.20% and F1 score is 64.81%, while NB net bias has the highest accuracy, that is 70.15%, and F1 score is for 75.10% in ML. In CNN model performance, the accuracy is 93.98%, the precision is 91.71%, the recall is 92.21%, and F1 is 94.32%. If we compare our work with other datasets, then we can see that our proposed model has the highest accuracy with 93.98%, while the other datasets has the accuracy is below 93. The key finding, we have found that CNN outperformed traditional machine learning models for autism spectrum disorder ASD diagnosis using facial images. CNN achieved accuracy 93.9% and F1 score 94.32%. Among traditional machine learning models, NB performed best with accuracy 70.15% and F1 score is 75.10%, while the SVM had the lowest performance accuracy 0.62% and F1 score is 64.81%. The CNN's superior performance underscores the potential of deep learning in autism detection, while the traditional machine learning models require more tuning to improve accuracy. Selecting the right model is crucial based on the classification goals. As the conclusion and future work, we can see that according to the data, CNN performed best when it comes to classifying ASD images with an accuracy of 93.98% and an F1 score of 94.32%. And naive Bayes was the most accurate machine learning model with an F1 score 75.10%, and support vector machines SVM were the least accurate 2.20% with an F1 score of 64.81%. And as the future work, we have included exploring and implementing more efficient features of this method. To increase classification accuracy, we can use more complex deep learning models such as transformer based architectures or sophisticated convolutional neural networks like EfficientNet. And as a reference, we have used the most relatable references according to our proposed work. Thank you so much, everyone.